All right, today we're going to be taking some notes on the Pythagorean theorem, which is something that is a big part of 8th grade math. So getting really good and solid at this skill is going to help you be successful for next year. So first, a couple of pieces of vocabulary for our parts of a right triangle. So you can see that our right triangles have that little box in the corner. Remember, that means that there's a 90-degree angle. And that 90-degree angle is always going to be there if it's a right triangle. So first off, our sides A and B are called legs of the right triangle. And then side C, which is the side that's across from that 90-degree angle, that right angle, is called the hypotenuse. All right. So first off, what is the Pythagorean theorem? So the Pythagorean theorem is a relationship between these parts of a right triangle, and it can only be used for right triangles. So if you have a triangle that is not right, you can't use this theorem. We can use it to find missing side lengths or prove that a triangle is right. And the special formula, which we're going to put inside this box, this is the super important part that is our Pythagorean theorem, is a squared plus b squared equals c squared. All right. So our first thing that we're going to do is prove if these three numbers, these three side lengths that they give us, we're going to use our Pythagorean theorem to decide if they make a right triangle or not a right triangle. So we have a hint here. It is that the largest number is used for C. So looking at our first example, we have 5, 12, and 13. So 13 is my biggest number. So that's going to be my C. So when I put these numbers into the Pythagorean theorem, it doesn't matter if you use A or B for the 5 and the 12. Those can be switched around. You can just choose. But the biggest number has to be used for C. So let's just go ahead and use them in the order that they have here. So I'm going to use 5 where the A is. So I'm going to write down 5 squared, because that's my formula, plus 12 squared equals 13 squared, because remember that bigger number has to be where the C is. So now I'm going to go ahead and start solving this and see if it works out. So 5 squared equals 25. 12 squared is 144. And 13 squared is 169. And now I'm going to add those two numbers together. So 25 plus 144 is 169. It does equal that 169, so that works out. So that means that yes, those three numbers make a right triangle. So let's go ahead and try number 2 here. So I've got kind of weirder numbers. I've got decimals, but I can still use my Pythagorean theorem to check. So remember, the biggest number has to be C. So I'm going to circle that one first. That 12.2 is going to be used in C for our formula. Let's go ahead and set this up. So 6.4 squared plus 12 squared equals 12.2 squared. And we're going to see if it works out like our last one did. So I'm going to have to use my calculator for this one. When I do 6.4 squared, I get 40.96. Plus, I already know 12 squared is 144. And then 12.2 squared is 148.84. So now I'm going to add those two together. So 40.96 plus 144 is 184.96. And I'm noticing that I'm getting a different answer here. So it doesn't equal that 148.84 that I was looking for. So that means no, these are not numbers that make a right triangle. So that's how we're going to use our Pythagorean theorem to prove if three numbers make a right triangle. So at the bottom of our note sheet, we've got two examples of using the Pythagorean theorem for a missing side, and I even have my steps written out here on the left. So our first step is to decide if the missing side is a leg, like letters A or B, or if it's the hypotenuse, which is for that letter C. So even though they've turned this right triangle for number 3, they kind of turned it around, so my right angle is not perfectly fitting like it was in my example, I'm still looking for the side across from that right angle to be C. So that missing side, I know that that one's going to be C because it's across from the right angle. And then 7 and 10, I can decide which one's going to be A or B. I'm just going to go ahead and pick A for 7, B for 10. Those ones, remember, it's okay if you switch them around. So let's go ahead and put these numbers and that letter into my formula. So now we're going to put 7 in for A. So I'm going to write down 7 squared. And then I'm going to use 10 for B. So plus 10 squared equals, and I don't know what C is, so I'm going to just keep that as the variable. So now I'm going to solve out what I know. So that 7 squared I know is 49. 10 squared is 100. I still don't know what C is, so I'm going to leave that as a variable. So then 49 plus 100, that's 149, equals C squared. So now this is the new step because we haven't really dealt that much with undoing those squares, but we know that the opposite of squaring a number is to take the square root. So I'm going to draw my little square root symbol for both sides, because if I do it on one side, I've got to do it on the other. And that's going to get rid of that little squared. So that's kind of the new tricky part. So when I take the square root of C squared, I'm just left with C. And on the other side, if I take the square root of 149, I get a long decimal, but I'm just going to write down 12.21. I'm going to shorten it up there. So that means that if my two legs of my triangle are 7 and 10, that means the hypotenuse has to be 12.21. And that one, I also am noticing that that matches, because remember, our largest number is our hypotenuse. So 12.21 is larger than both 7 and 10. So I know I'm on the right track there. All right, for number 4, we have a little bit of a typo. So you're going to do this on your note sheet with me. So cross out that number 7. That's incorrect. And then we are going to label that other side 5. Okay. So first I've got to go ahead and label my sides here. So remember, look for that right angle first. The two sides that make the right angle are the legs of your hypotenuse. So A, I'm going to put for 3, and that other side that I don't have a number for, that's going to be B. And then the side that's across from the right angle is our hypotenuse, or letter C. So let's go ahead and put these numbers into our formula. So A squared plus B squared equals C squared. So I'm going to write down 3 squared plus, I don't know what B is right now, so I'm going to put B squared equals, and I do know C, so I'm going to write down 5 squared. So this one, since my unknown variable is kind of mixed into that equation, it's almost like I'm going to draw my railroad tracks and try to solve this. So let's go ahead and solve out those ones that we've squared. So 3 squared equals 9 plus B squared, still going to keep that like that, and 5 squared is 25. All right, so remember, we're always trying to get the variable alone, so that means I have to get rid of adding 9. So I need to subtract 9 from both sides. And now I'm going to have left over B squared on the left and 16 on the right. All right, again, if I want to get rid of a square, I have to take the square root, and the square root of B squared is B, and the square root of 16 is 4. So that means that that missing side length would be 4. All right, so on the back of your note sheet, we have 4 examples that we're going to go ahead and try, and there's a lot of lines there. That's to help you organize your work. So remember, you always want to start out with your formula and substitute in the numbers that you know. So label it on your picture, put it into your formula, show each one of these steps. Because if you are neat, your calculator does a lot of the work for you. You just got to make sure that you're keeping track of where the numbers go.